Chapter 6 Schrödinger wave equation and semiconductors. The subject of wave equations may have an alarming ring of difficulty. However, by learning how to interpret the meaning of a wave, the difficulty is diminished. After reading Chapter 9 on waves, you may want to return to this chapter again. For an introduction to the subject of wave phenomena, I recommend 3 books that explain the problem of wave interpretation: Quantum Reality by Nick Herbert, In Search of Schrödinger's Cat by John Gribben, and The Dancing Wu-Li Masters by Gary Zukov. Written for non-physicists, these books reveal the seemingly impossible task of contemporary physics to explain a wave's relationship with particles. Learning the difficulties with current interpretations of these relationships may be helpful in understanding my interpretation. I will use these interpretations as a guide to solving these wave problems. The Viennese physicist Erwin Schrödinger made important contributions to quantum mechanics with the development of his mathematical wave equations. These equations have been essential in the development of our most advanced technology. This discussion will be directed to the difficulties of current attempts to explain these wave equations. We will begin by summarizing how physicists describe the wave function of Schrödinger's equations. The wave function somehow incorporates a particle within the propagation of the wave. The wave occurs in isolation between 2 regions: the region of preparation, where the wave begins, and the region of measurement, where the wave ends. Information concerning the apparatus involved with the region of preparation and measurement is entered into the equation. As the wave begins, there is a continuing mathematical development of the wave. This development shows the constant changes of the expanding wave, which includes its proliferation and a continuous unfolding of the multiple possibilities of the particle's location in the wave. This continuing and changing mathematical expansion for the wave occurs only between the region of preparation and measurement. If the amplitude of the wave function is squared, it reveals a probability function. The probability function is a calculation that predicts the probabilities of the various locations a particle will reveal itself when located at the region of measurement. The probability function is a prediction of how likely it is for the many positional possibilities of the particle to occur. When measured, any of the possibilities for position can occur, but some have greater probability than others. The mathematics only describes the probabilities of the possibilities of the particle's position, and this determination are only at the region of measurement. The wave function data are not specific about a precise location for the particle during its involvement with the wave. The wave function only gives the probabilities of a multitude of possible positions prior to the decision to measure. Physicists are commonly perplexed by the wave function. Why does the wave give so many possible locations for the particle? It is believed that the macrocosm there is only one identification of position during momentum, motion. Why all the possibilities in the microcosm? At the macro level, at any given moment, there is only one place for object to exist. Whether we look or not, we have confidence of determining a location for an object during its motion. But in the microcosm of the wave function, there are myriad possibilities of position. In the domain of quantum mechanics, we cannot be sure of anything until we look by measuring. A basic problem for physicists is that at the microcosmic level, they are assured of determining the position of an object during motion, while at the subatomic microcosmic level, the equations, wave function, will not allow the determination of a particle's position during its motional propagation within the wave. The question is, why will the wave equation not permit an accurate determination of a particle's position at any moment during the wave's proliferation? This apparent contradiction between the microcosm and macrocosm has created a crisis for some in the scientific community. Some physicists have concluded that cause and effect is inoperable in the subatomic realm, and that the macrocosm and microcosm are governed by different rules. Because of the particle's multiple possibilities of position at any given moment, some have concluded these possibilities are only a potential for a particle to exist in a wave. It is said the particle is a potential entity at every place indicated by the possibilities of position. In some way, all of the particle's possibilities and none of the particle's possibilities occur at the same time. Another interpretation states the particle is part of all of the possibilities of position, and only one possibility can be actuated by its measurement, observation. Some say that it is the observer and his observation that makes possible a particle's existence. Somehow, upon human observation, measurement, the particle mysteriously presents itself, and its marvelous multidimensional presence within the wave becomes a normal three-dimensional existence. Some have generalized this to include the entire universe. This view states that universal existence can occur only when the observer interacts with the observed. Until we look, observe, all of the possibilities of position are held in suspension. The conclusion is that existence is actuated only by our observation, that objects are at an infinity of suspended states until we observe. Only when we look will objects materialize at one particular state. A full circle is reached by a return to the posture that we are at the center of and the cause of universal existence. Physicists only seem capable of providing an existence for the particle before the beginning of the wave at the region of preparation and at the end of the wave at the region of measurement, observation. During the wave, physicists can say nothing about physical entities except that they are in a state of limbo, being everywhere and nowhere, a condition between existence and non-existence. The equations of the wave function reveal the wave as an expanding process which occurs over a large area, while a particle is a local entity that occurs at a small area. The wave somehow involves the wholeness of non-local conditions. The question is, how can the local and separate nature of the particle be part of a non-local and much larger wave? Because of these local and non-local differences, a wave shows itself only as a wave and a particle shows itself only as a particle. For the physicist, there is either a wave or a particle, one or the other, but never both at the same time. The dilemma in particle physics is to reconcile how the waves and particles are related to each other. During the wave, we cannot define the wave's relationship to the particle, and when the particle is defined, it is not part of a wave. During motion, there is a wave, and at arrival with a measuring device, there is a particle. The potentiality of a particle being many places within the wave changes during measurement to its measured appearance at one place. This measured appearance is called the collapse of the wave. When measured, the particle shows itself, and at the same time, the wave ends in collapse. The problem this raised was, what is happening to the particle between the region of preparation and its appearance at the region of measurement? How do particles and waves exist as a part of each other? One can imagine the concentration of physicists in contemplating a subatomic world without apparent cause and effect. It was a major departure from the classical perception of reality. These quantum mathematical questions cannot be cast aside, because their solutions are correct. An outgrowth of quantum mechanical applications has given us much of our modern technology. This includes transistors, superconductors, nuclear power, computers, and laser technology. While quantum applications to certain technologies have been spectacular, quantum interpretations and quantum reality remain an enigma. Various interpretations of Schrödinger's equations were made by various physicists after Schrödinger had published. Schrödinger was unreservedly disgusted with quantum jumping, the wave collapse, and other departures from classical reality. To show the absurdity of these explanations, or lack of explanations, Schrödinger developed a now famous thought experiment. A cat is placed in a box, and a device inside the box is designed for the random decay of an atomic particle. The release of a particle will activate a poison gas that will kill the cat. The odds are even that the poison gas will or will not be released. The cat has a 50-50 probability of survival. The experiment is activated without human observation, and the question is raised: if humans do not look, will the cat die or live? Typical quantum interpretations claim that until the observer looks, the cat is between extreme possibilities. The cat is neither dead nor alive until humans actuate the alternatives by looking. All possible states, alive or dead, exist until activated by the process of looking, measurement. Prior to human observation, there is only a potential for a subatomic occurrence. All possibilities and no possibilities exist until we look, that is, observe and measure subatomic phenomena. This sounds preposterous, and the aim here is to reach interpretations that are consistent with observation and reason. Schrödinger's thought experiment links the microcosm with the macrocosm with a radiating atomic particle. The absorption of photons, light particles, from the sun links the necessary intertwining between humans and microcosmic particles. With his thought experiment, Schrödinger is suggesting that there can be no real separation between humans and the microcosm. By applying rational analysis, it becomes obvious that there is a problem with these typical interpretations of quantum physics. How can these irrational interpretations be replaced with rational explanations that acknowledge cause and effect? Schrödinger's cat will be either dead or alive without our looking. There have long been attempts to show the necessity of a human presence to activate existence with this proverbial challenge. If a tree falls in a forest and there are no humans present, will there be a sound? The implication is that natural phenomena are dependent upon human presence. However, the absence of human observation and interpretation of these oscillating waves of air as sound does not deny the existence of these waves. What about other absorbers of this energy, plants, rocks, soil, and trees, that are not human? Energy, nonetheless, is still absorbed and transferred through all objects. Humans responding to sound waves, one form of energy absorption, have interpreted and labeled this class of absorption as sound. Do we really understand the complexity, methods, and response to the absorbing techniques of non-human structures? Human minds absorb energy in many different ways, which include observation, and we use language to describe it. But there is a universe of other structures that absorb and also react to their absorption. Do our techniques and reactions to energy assimilations make us the centerpiece of the universe? Is human absorption the supreme absorption in nature? Are we qualitatively superior to the energy ingestion dynamics of the atomic and subatomic realm? All objects absorb and emit waves of energy. Humans have their processes of absorption and emission, and other structures have theirs. I believe the atom has more versatile emission and absorption processes than do humans. The atom's time frame for development is certainly longer than our human time frame of development with its recent emergence. In our attempt to understand the nature of position and motion, what have we missed that gives us conclusions defying observation and reason? Should we accept this departure from causality? Have we forsaken rational explanations of the atomic world and then attempted to extend this irrationality into the macrocosmic world beyond the atom? Some insist that it is a waste of time to change this nonsense into sense. Must we continue to live with these illogical explanations? It is time to admit our ignorance and continue the search for rational foundation of atomic structure. The basic problem is this: why does the nature of the wave function disallow access to its inner workings? How can we come to positional knowledge of an object's motion in the macrocosm, and yet in the microcosm this knowledge is denied? Why do the wave equations deliver only the possibilities of a particle's location instead of its actualities of location? Zeno's paradoxes were solved by disclosing the fallacy of reaching positional points of set locations while motion continues. The difficulty in interpreting Schrödinger's wave equation is directly related to Zeno's paradoxical misinterpretation of motion. Quantum mechanics is a study of microcosmic motion. The physicist's dilemma in explaining Schrödinger's wave equation is tied to his concept of motion and its relationship to position. The inability to simply explain Zeno's paradoxes is for the same reason. It is time to see a different relationship between an object's motion and an object's position. Since Newton, the rate of motion has been determined by placing specific locations of position on motion during motion. Position is essential for defining motion, and this creates, however, a mindset that position and motion are simultaneous. Physicists, to my knowledge, have never questioned the idea that motion, momentum, and position are synchronous events. Has it never occurred to them to doubt the possibility that position and motion are not synchronous, simultaneous events? The resolution to Zeno's paradoxes is to remove fixed locations of position on the path of motion by concluding that arrival, position, cannot be part of the journey, motion. This opposes current concepts of motion. However, this does not oppose the necessity of imposing an assumed position on motion for reaching a definition for motion. Instead, solutions for Zeno's paradoxes forbid the notion that actual position, a fixed location, occurs during the motion of the observed relative to the observer. For an understanding of motion during motion, there is the necessary assumption of position. That is, this is where the object would have been if it did have an actual position. Schrödinger's wave equation involves the motion of a particle, the wave involves motion. To remove the belief that we should be able to impose fixed position on the particle during its motion is to remove the difficulty in interpreting the equation. To separate position from motion, one after the other, is paramount to our understanding because the wave is solely and exclusively involved with motion. In actuality, motion and position are two separate stages where the stage of motion, emission, is used to reach the stage of position, absorption. If emission and absorption represent the basis of how objects interact, then let us use this duality to interpret the wave and the particle and the jumping that cause a wave to collapse during interaction with a measuring device. If emission is the stage of motion, momentum, for a particle, then absorption represents this separate stage of position. The key to understanding why the wave equation does not give us actualities for position comes with the realization that a wave involves the emission of a particle and not its absorption, position. To regain cause and effect within the wave function, let us consider the possibility that a wave is associated only with the emission stage of a particle. The separate wave stage is associated only with a particle's motion used to reach the separate stage of position. The collapse and cessation of a wave is a collapse and cessation of the particle's motion. A wave is the departure stage of the particle leaving a hole, while the arrival stage ends the wave motion when the particle enters the hole of the measuring device. Is the change from a wave to a particle, collapse of wave, at the measuring device merely a particle's change from the separate stages of emission, wave, to absorption, measuring? For reaching logical conclusions, it must be clear that all of our defining processes are processes of measurement and that measurements are part of the stage of absorption. Measuring devices are human extensions of observation for reaching mental absorption. The wave is the emission stage reaching for the next stage of absorption, position. The absorption stage is the measuring stage that collapses the wave, emission stage. Is the beginning, start, of the wave at the region of preparation necessary to reach an end, stop, of the wave at the region of measurement? Is the region of preparation a prior positional requirement for the particle's start of motion, emission, and wave? Is this start necessary to reach the stop of absorption, measuring? Is the region of preparation the same as the arrow within the drawn bow? And is the particle's arrival at the region of measurement the same as the arrow's arrival at the target? Is the arrow's motion an isolation of motion, wave, between the arrow's non-motion at the bow and the target? Is this the same as the particle's motion in isolation between its non-motion at the region of preparation and the region of measurement? The answer is yes to these questions. A conclusion is that the motion of all objects is a stage of isolation between the stages of non-motion. The wave function is indicating this through the wave's isolation between the region of preparation and the region of measurement. The wave of emission is always isolated, separated from absorption. The human isolation from motion is used to join together the non-isolation stage of mental absorption. Opposites are again showing themselves where the opposite apart phase of motion is necessary for the together phase of absorption, non-motion. The non-recording event of motion is necessary for the recording event of non-motion. The act of not measuring, a part of emission, is a required condition prior to measuring, which is a part of absorption. An off emission and wave is necessary to have an on absorption and wave collapse. Wanting to find position within the wave is like wanting off and on at the same time. The wave stage, motion, by itself can never become a part of awareness and knowledge. Motion can never be a direct experience of itself. Motion is used to reach a direct experience. The inability to look at a wave has always been a requisite to looking. The wave is a required period of non-measuring that must occur before measuring. The wave of emission can never be a direct part of knowledge. Rather, the wave of emission is used to reach knowledge. Ignorance is part of the wave that collapses with knowledge. For the human mind, the collapse of the wave is the collapse of ignorance. This shows the necessity and value of ignorance. Without ignorance and the empty, zero, a wave would be unable to reach the fill recording necessary for knowledge. What happens with the attempt to change the wave's possibilities of position into actualities of position as the wave continues? This is an attempt to interject the stage of absorption into the stage of emission. It is another fruitless effort to impose fixed locations on motion while motion continues. The paradox is itself imposed by the presumed, obvious but erroneous assumption that actual position and motion are simultaneous. The different events of position and motion are understood by the recognition of the whole, zero. Emission is the motion of an object leaving a hole, and absorption is the position of an object reached by entering a hole. The wave function of Schrödinger's equations describes what has always been a part of nature. Physicists want definitions during the wave where the necessary non-defining stage is occurring. To want fixed locations in the wave is an attempt to want to make ignorance and knowledge, arrival and departure, on and off, simultaneous events. This is like eating our cake without the prior necessity of bringing it to us. The function of the wave is to bring the particle to us. The wave can never be a direct part of our experience. The wave is an indirect process, all as in all motion, used to get to a direct process. The illogical interpretation that a particle exists everywhere and nowhere during the wave's propagation can now be reinterpreted. The wave does not deny the particle's existence, but it does deny a place for the particle to exist in. There is no specific fixed location for the particle during the wave because the particle is yet to have a relationship with an absorber. The concept of where must involve both the observer and the observed. The observer is the absorber, and the observed is that which is absorbed. Mental absorption for humans is an arrival at definitions which are positional processes. The wave involves the particle that does not yet have access to an absorber. With arrival, the particle now becomes the observed because it has been absorbed by the observer. The act of absorption is what defines an observer. An observer is an absorber. Humans, instead of providing an existence for objects by looking, are providing a place for objects to exist in. Everything in existence does not always have a specific fixed place, zero, to reside. The purpose of motion is to reach an arrival process for what does exist. During the wave, we will never know where the object is relative to ourselves or anything else. By looking, observation through mental measurement, we give the particle a place to reside. The interpretation of the wave function that particles only have a potential to exist during a wave can now be discarded. The potential of particles in motion, wave, is a potential for particles to reach the absorption stage. It is a particle's potential for existence within a specific hole, place, provided by the absorber. The potential is the possibility of where the particle may exist instead of its existence. An object in isolation, in motion, still has the existence of all of its physical and non-physical attributes. The only thing it does not yet possess is an absorber. The object in motional isolation does not yet have a relationship for defining its 0 and 1 characteristics. When humans mentally absorb, they gain information. Once absorbed, information has a place to exist and is stored in the mind for immediate and future use. The wave function gives a continually changing description of all the possibilities of its position when the observed particle interacts with an observer measuring device. Understanding occurs by realizing that possibilities are always part of motion, wave. Possibilities are possibilities of position that cannot and will not occur during the wave, motion. This is the way nature works. The terms possibility and actuality are opposites that are necessary to derive each other. Actualities are part of arrival, measurements, and a defining process. Possibilities are part of the possible interrelationships of the one and the zero. The possible is the one of the object having access to the zero of the absorber. The possible moves to the actual when the one of the object enters the zero of the absorber. The zero of the possibility is removed by the one of actuality. Possibilities within the wave, motion, are the number of possible holes that may be available within the space zero and the particle has access to. This space zero, used for the particle's propagation, provides the space for the particle's eventual fill by the zero of an absorber. The nothing of space provides an infinite number of possible pathways and holes for matter to organize. Zeno showed the infinite possibilities of holes for arrival with the halfway points for the runner. This infinity of possibilities provides answers for why the wave function cannot predict with accuracy at which hole the particle will arrive. A question to consider is, where will the particle be for absorption when space zero can access an infinity of possible places for absorption? How can humans predict future possibilities with accuracy when those possibilities are infinite? This describes the concept of chance. Where there is chance, there are infinite possibilities for absorption of objects in motion. There is no possibility of predestination if destinations, zero, are infinite. How can position be foreordained if all the possibilities cannot be determined? Where there is infinity, all does not apply. Where we arrive always involves an element of chance. The where in arrival can never be predicted with absolute certainty. For this reason, all action is a part of chance. The wave function at best can only show probabilities of the possibilities. Probabilities indicate a greater likelihood for the future events of arrival. Humans also use probabilities for reaching their positional defining processes necessary for survival. Understanding the probabilities reduces the chances of failure. It is the infinity of the possibilities of arrival that requires the wave to give us only probabilities. Instead of the particle being involved with all the possibilities, the particle within the wave is not yet part of any possibilities. Possibilities are those of position not possible in the wave. The particle is involved with motion, wave, and not position. The term possibilities is a reference to what may happen in the future when the particle reaches its position, absorption. To require that position be a part of the wave is impossible. It is an attempt to inject non-motion on the object while it still moves. The wave function is pure motion, and to inject arrival upon it eliminates the wave. There is more to nature than waves, motion. The physicist's focus on motion is like his monocular focus on the physical. Newtonian and quantum mechanics are the study of motion. The mistake is in concentrating only on motion when the y of motion is position, absorption. However, it is easy to focus on motion when position and motion are conceived to be simultaneous. Comprehension is accomplished when any subject's opposite is included in the analysis. To perceive motion and position as opposites, and that opposites, the term possibilities is a reference to what may happen in the future when the particle reaches its absorption. Position. To require that position to be a part of the wave is impossible. It is an attempt to inject non-motion on the object while it still moves. The wave function is pure motion, and to inject arrival upon it eliminates the wave. There is more to nature than waves, motion. The physicist's focus on motion is like monocular focus on the physical. Newtonian and quantum mechanics are the study of motion. The mistake is in concentrating only on motion when the way of motion is position, absorption. However, it is easy to focus on motion when position and motion are conceived to be simultaneous. Comprehension is accomplished when any object's opposite is included in the analysis. To perceive motion and position as opposites, and that opposites occur one after the other, should be convincing evidence of their inability to coexist simultaneously. In the why, what for of motion is introduced, it implies the question of whether or not teleology exists. The implication that motion may have a reason to occur suggests there is more to nature than motion. What is at the end of motion? The why of motion is in reaching and entering the positional whole of the absorber. Contemporary physics does not show the interrelationship between the wave as a large expanding non-local concept and the particle as a small finite local concept. The salient question is, how can a wave be part of a particle and a particle part of a wave? It appears that a wave is different from a particle. But what if waves and particles are dependent upon each other? Instead of trying to view them as having a separate existence, consider that one is impossible without the other. This is a part of corollary number 1, stating the necessary interdependency of the binary 0 and 1. Is the wave a part of the non-physical 0 that the particle 1 is dependent upon? Should we incorporate the non-physical 0 and the physical 1 in explaining the nature of quantum waves as well as all wave phenomena? A football game will be used here to describe this relationship between a wave and the objects involved with a wave. Football stadiums are constructed to organize fields of play for the games. What are fields? In football, fields are used to organize space, holes, for the emission and absorption of actions used by the players. All physical 1 action requires the use of fields 0. The motion, emission phases of the ball and players are wave phenomena. The field has a prime hole, which is the goal of the game. The player's wave emission is to reach the goal. As in all natural phenomena, the goal is to enter the hole. As in particle physics, the goal of the particle motion is to reach a hole, which is provided by the measuring device. Upon entering the hole, the wave collapses, ceases, and positional absorption takes place. As the players move toward the goal, the wave is expanding and proliferating. This can be envisioned if we consider the continuous geometrical changes that occur to the field 0 as the wave, 1 of players and 0 of field, advances. There can be no change to the field 0 if the players 1 are not involved. Both the 0 and 1 are necessary for all universal action. As the player's 1 motion advances, the size of the wave and its associated field 0 becomes larger. The amount and size of the field 0 being used expands. To understand a wave and its relationship to the physical of all objects, it is necessary to include the expanding and proliferating changes of the zero's geometry, as the physical part of the players manipulate the field with emission. The non-local and the larger concept of the wave is the field of organized space that is an integral part of the wave. As the players use more of the field continues to expand. The other part of the wave includes the finite local concepts of the players. The wave is always a synthesis of the physical players and non-physical field. The large part of the wave is the field that the small part of the wave, finite physical, is using. The larger size of a wave exists because it includes the particle's use and involvement with its field, zero. The failure to identify the wave and its essential field of nothing is the same failure to identify the essential field, empty column, of the counting board. In a like manner, when watching a football game, the viewers concentrate on the ball and the players. They are not directly aware of the spatial, zero, relationships to the physical, one, that make the game possible. This is analogous to viewing a particle. The focus is on the physical, one, and we disregard and are insensitive to the zero field that the physical uses for its occupation and propagation. A wave cannot exist without a physical, one, and a field, zero. The field is the medium of motion for the physical. The wave has the binary phenomena of both the zero and one. The local physical is always a partner of the non-local, non-physical. The opposite terms local and non-local are showing their interdependent binary foundation. The wave equations of quantum mechanics are involved with the fields of non-matter. Newtonian mechanics is more directly involved with matter. The wave function is unique in that it is limited to the emission stage of motion. The wave function is involved with the nature of the expanding and changing field of nothing. The wave function's description of motion necessarily involves the limits of motion. It is the limits of a concept that give us the contrasts, opposites, necessary to understand the concept. The limiting factor for the wave is position. To understand a wave requires the opposite concept of the object's position at the start and at the end of motion, wave. To understand the idea of motion, it is necessary to contrast motion with the idea of non-motion. The contrasts provided by our binary universe give us awareness. The wave function elegantly describes the microcosm with the continuous changing and expanding geometry of nothing, field. The geometry of nothing changes as the motion of particles changes. The physical of the particle is necessary for the changing dimensions of the field, zero. The physical during motion creates changes in the non-physical's geometry. When the one changes, it changes the zero. These continuous changes create the inability to define the particle. The collapse of the wave collapses these changes, allowing a stationary field, zero, for absorption and knowledge of the object. We can now revisit the cat in Schrödinger's thought experiment. Cause and effect are necessary to explain the problem. The use of cause and effect implies two stages, one for the cause and the other for the effect. Does this have any relationship with the two stages of emission and absorption? I propose that emission and absorption and the forces of attraction and repulsion are the foundation of cause and effect. The forces of attraction and repulsion are a part of the dual stages of emission and absorption. Cause and effect involve the one and zero and their attraction to each other. It can be stated that the cause of all motion is for the effect of reaching position. The force of repulsion guides this attraction during emission to absorption. Absorption is provided by the zero of the absorber and the one of the absorbed. Quantum interpretations indicate that until we look, Schrödinger's cat cannot be either dead or alive. The cat is held in suspension between both life and death. By physicists arriving at this interpretation of the wave function, it paradoxically makes humans the only observers in a universe that absorbs. Our first step is to understand that the wave function deals only with the stage of emission. The next stage is absorption, measuring and observation. To say that the cat is neither dead nor alive until we look, it is to state that only humans can culminate and collapse the wave through absorption. This is not the case because the motion of the wave of released poison can be terminated, collapsed, by the stage of absorption provided by the cat. To state that a cat is neither dead nor alive until human absorption, is to inadvertently set ourselves up as the only absorbers in the universe. However, the universe is a composite of structures that are both absorbers and emitters. The wave equation is involved with emission, and this is only one part of nature's two-part binary system. The cat is always capable of collapsing by absorbing the wave of poison gas, which is triggered by the release wave of an atomic particle. The collapse of the wave of atomic radiation is when it is absorbed by the poison container. This in turn produces a wave of poison gas which collapses with the cat's absorption of the poison. On the other hand, if the cat does not die, there has been no wave for the cat to collapse, absorption. There is no wave unless atomic radiation is released. When humans finally look, observe, to determine the condition of the cat, they also collapse a wave. An emission of a wave of photons is reflected from the cat to reach absorption, vision, by humans who identify whether the cat is dead or alive. Information of a dead cat is reached by our collapsed absorption of a wave of photons showing the cat's previous collapse, absorption, from the poison wave. Information of a live cat is also reached by a photon wave collapse showing us there was no poison wave released. Through a rational analysis of Schrödinger's thought experiment, our perception of cause and effect is returned to the microcosm. The attempted removal of cause and effect from the microcosm while retaining it in the macrocosm is not possible. Cause and effect are irrevocably connected for all nature. The cat problem and its solution reinforce the idea that without an understanding of cause and effect, ignorance, zero, emerges. With the recognition of the zero of ignorance comes the opportunity of replacing it with the one of knowledge. To believe that cause and effect are unavailable in any area of nature decreases our survival capabilities. If the ignorance of a whole exists, there will always exist the possibility of combinations of the one to fill the whole of ignorance. The impossible exists only if we cannot create both the whole and the one to fill it. The building blocks 0 and 1 are always available. When illogical interpretations are used, it usually means that ignorance 0 is faced by more ignorance 0. This is the non-progress of repulsion 0 to 0. Forward motion towards solutions is prevented by only relying upon past knowledge. This is a one-to-one of repulsion where only past knowledge 1 confronts past knowledge 1. There is no arrival of new knowledge. This is why new ignorance is essential, because it supplies a new 0 for the new 1 of knowledge to fill. It is the realization of ignorance and not knowing which makes available the 0 that stimulates us to fill it with knowledge. When we could not explain the paradoxes of subatomic domain, we created pseudo-knowledge by concluding there was no cause and effect. This is having the 0 of ignorance and deciding it was meant to be a permanent feature of the mind. However, the 0 of ignorance is designed for the fill of knowledge. Our present evolutionary status indicates there can be no exceptions. Our survival is dependent on these continuing mental oscillations between ignorance and knowledge. a rational interpretation of the wave function simplifies its understanding. A wave is the motion of matter using the field of nothing for its propagation. The wave function shows the large and non-local expanding nature of the field's zero geometry as it relates to and is used by the small and local matter. The wave is used to approach the possibilities of ending the wave by matter entering a specific hole and establishing position. The collapse of a wave is a collapse of the motion required to enter the hole of absorption. As matter reaches position, it no longer requires the use of the field of nothing for its propagation. The expansion and proliferation of the geometry of the field of nothing is discontinued when matter arrives. Matter no longer provides the motion of its physical borders to enable the field's continual changing non-physical borders. The field 0 becomes stationary upon the arrival of matter 1 because matter has no motion outside the parameters of the whole. Semiconductors. In solids such as metals, electrons are bound tightly to the nucleus within valence bands. There are also bands that allow electrons to wander around from atom to atom, and these are known as conduction bands. In a semiconductor, the valence bands are filled with electrons, and there is a narrow gap between the valence bands and the conduction bands. This allows electrons within the valence bands to move into the conduction bands when they gain sufficient energy. Current views in physics correctly state that the resulting absence of the negatively charged electron within the valence bands leaves behind an empty hole that acts like a positive, in reality negative, charge. This confirms the correctness of Franklin's reasoning with his excess 1 and deficit 0, and relates the excess addition to a positive 0 charge and a subtraction deficit to a negative minus charge. The electron's jump into the conduction band creates an excess within the conduction band and a deficit within the valence band. Semiconductors occur in nature. We have created synthetic semiconductors, some with an excess of holes and some with an excess of electrons, 1. The combinations of these positive 1 and negative 0 semiconductors form the basis of digital computers. Beyond computers, these combinations of 1s and 0s are necessary for all working systems. It is important to note that a hole, deficit of electrons, is said to have a charge. Are we one step away from making the hole responsible for all negative, today called positive, charges? Where the hole is filled, this creates the positive, today called negative, charge. In reality, emission creates the empty negative minus, and absorption creates the filled positive plus. Resistance to this new view may result from its simplicity, and yet this is a large part of its corroboration. A goal of understanding nature should be to minimize the amount of information necessary to explain natural phenomena. To recognize that the whole has a charge, minus, is the key to understanding the wonder of the oscillating emission and absorption universe. This recognition provides an identity for the partner 0 of the physical 1.